everyone. Welcome to LineaPy workshop. We have prepared lots of cool stuff today, so we'll just kick right in. Housekeeping items here. Every week, we're working on a bunch of the innovations, so make sure to join our Slack for the latest update and event announcement. If this is your first workshop, which previous recording from YouTube, mark your calendar for the next API Basics workshop at August 5th. You will learn a high-level overview of what LineaPy can help you with your data science work. Okay, first thing first, I want to announce the best community contributor of June. Immune Lee updated Get Ignored for contributors who use virtual environment by following the contributing markdown. Thank you, Enming, for your awesome work. This is a very high level contributions, and the full LineaPy swag package is on the way. First thing first, let's get the pronunciation correct. It's LineaPy, that's how you say it. Linea stands for the lineage between code, and Pi stands for Python. So what is the problem LineaPy trying to solve here? There is a huge gap between development and production. One of the biggest reasons for that is the tools used for two sides are vastly different. For the development side, you have tools like Python and Jupyter Notebook that data scientists use to do analysis and modeling. On the right, you have tools like Spark and Airflow that data engineers use for scalability and uptime. Only 13% of all the pipelines are actually put into production, which sounds like a huge waste of time and development efforts, right? As you can tell from the name, we're working on leverage lineage to bridge the gap in between, making sure months of data science development does not end up being wasted. LineaPy is an open source Python library that was built to automate the engineering that happens after data science development. It helps to build data pipelines and put them into production. Normally, this whole process takes weeks to months. With LineaPy, it's just 2 lines of code. Sounds like magic, right? In the workshop, we will introduce you to the many different ways LineaPy can make your life easier as a data scientist, data science student, data engineers, or machine learning engineer. A quick note on that, experience with Python, Docker, and Airflow will provide a very helpful background knowledge, but the workshop today is completely self-contained, and the knowledge about these tools is not necessary. Here's the agenda for today. We will first give you an overview of LineaPy, then we will go through the notebooks walkthrough. We will have Q&A following the walkthrough by the end of it to share more about the upcoming events and the social channels we have. Zoom in a little bit, here are some details on what goes on behind the scene and how LineaPy can empower your data science work. The first step is to import LineaPy. LineaPy is a Python library that you import into your development environment, which can be anything ranging from a Jupyter Notebook, VS Code, Databricks notebooks, Google Colab, or just an old good Python script. The import statement at the top automatically capture a start to tracking mechanism, which captures the entire development history and initialize the LineaPy backend database. During development, LineaPy is capturing a workflow and building what we call the linear graph. In the background, by analyzing your code, the graph captures dependency information about how different operations in your code are related to each other. Then when you call lineapy.save on any data science artifact, which can be a model, a data frame, a statistics, a chart, or anything else that is a data scientist is developing. In LineaPy, artifact is a fundamental unit. As data scientists, we work on models, tables, charts, data frame, but deep down, none of them can be simply understood as a sequence of operations leading from inputs to the outputs. What the LineaPy operation does, it extracts a linear artifact that contains both the value and the code for generating that artifact, along with the execution context, like what libraries are needed and what time it was for the first run. The code we're saving here isn't the raw code in a notebook, which is often messy because we're moving fast and jumping around during the development part. What we save is a cleaned up version that contains only the necessary operation to compute that artifact. And we do this by analyzing a linear graph that we have built in the background. This artifact store term might sound not familiar to you. Don't worry, we got you covered. Let's walk you through this in details with our engineer Sangyun. If you like to follow along, you can either scan this QR code and find the Colab button on the README. We're using Colab today so that we can get started without having to set up a local environment first. Over to you for the demo, Sangyun.
People. Okay. Yeah, first of all, if we actually want to do this type of collaboration, then we actually need to have a common storage space where we actually store the stuff, and then we can retrieve the work from each other. So in LineaPy, this happens to be something called the artifact store. And the cells that you see here are connecting to the artifact store hosted on AWS. Specifically a Postgres database and S3 bucket. So this first cell sets the connection to Amazon RDS, which is a Postgres database. And the second cell sets up the connection to S3 bucket on AWS. And because AWS comes with some setup work that we have to do, I tried to save some time for us. So I've already run them. So we're currently connected to AWS. So we're connected to the shared artifact store. So what that means is that we should be able to actually query this store. How you do this is actually using this API called the artifact store. We've already imported this library, LineaPy, and we just use the artifact store. And when we actually run that, you will see artifacts here pre-populated, so you can consider it as a test work from somebody else. And let's say I'm a data scientist, and I actually want to build some, like a prediction kind of a process. So I want to make some predictions out of using one of these pre-trained models. And let's say we're actually interested in using this model, iris model. And as you can see, the artifact shows the artifact name, which is an iris model. And the number actually denotes the version number 2. And of course, this is the timestamp when it was created. So if I want to actually retrieve this one and use it, the API that I have to use is this thing called the Lineapi.get. And how you use it is you have passed in the artifact name and the version number that you desire. And it'll give you the artifact object, which will be held in this variable. But as Andy said, LineaPy, the thing that's special about LineaPy artifact is that it's both a value and the code. So because it has both the value and the code, we have to use a method that's called a get value to actually extract the value out of this artifact. And not surprisingly, this is a model artifact, so the value happens to be the model, and specifically, it happens to be a linear model. Okay, now that the model is loaded, this is pre-trained, so we got the information that this was somebody else who trained this model. So all we have to do is create the data to make some predictions on. So for that, let's actually make some fake data to make some prediction. And to give you the context, I got this context as a data scientist from my colleague that this model, what it does is it actually uses the physical trait information about iris flower and try to predict another trait about this iris flower. So as you can see, the predictor variables include petal width and whether it's a varicolor species and Virginica species. So basically, what I'm trying to do here is using the species information as well as a physical trait. I'm trying to make a prediction on another physical trait of the flower. So if I run this and check the data that we created for the prediction, this is what it looks like. Again, these are predictor columns. And of course, we want to use these variables to make a prediction. And the prediction we're trying to make is a septal width, which is another physical trait. So we're trying to basically make a prediction about these 5 records. And let's actually save this into the database, into the data frame so that we can actually examine the prediction. And if we run this, and I'm using model.predict, which is not surprising. we can see that the table now includes another column, which is a prediction column. So basically, we used these columns to make a prediction here. And it looks good, except that when you actually look closer to the eyeball the numbers, we kind of realize that something weird is going on. Namely, that this column and this column happen to have exactly same values. And of course, as a data scientist, we know that the chance of this happening is very slim. So this looks very suspicious, and we become very skeptical about the model. So our sense is that there's something wrong with this model. I want to actually pause at this point and think about what we can do next. And so as a data scientist, again, we got this model from somebody else. And then we try to use it, and something weird is happening. So what do we do? Normally, we would try to identify who produced this model in the first place. And if we actually can find that person, we're going to go to the person and ask what code they used actually to produce this model. But there's some problems here. First of all, we may actually not know who exactly produced this model. And second of all, even if we know who produced this model, when we go to them and ask them how they produced it, they may actually forget. And also, they may actually remember where the code is, but it may happen that they have actually overwritten. They have overwritten the code, which actually leaves in the middle of nowhere, because then we don't know how exactly this model came into being. Therefore, where the debugging has to happen. Okay, I'm going to actually assume the worst case, which is like that person. We know like it's John who produced this, but then people say John is not in the organization anymore. He left the organization, and he was in a hurry, so he didn't transfer his knowledge about this model. So nobody knows where the code is. So let's assume this is a scenario, and this is where LineaPy actually comes in and can help us to trace back where the problem happened, so that we can actually fix this. So as Andy said, and as I emphasized, LineaPy artifact, the special thing about it is that it's both value and the code. And what that means is that we can actually inspect the code that generated this value in the first place. So the API you can use for that is something called get code. It's a method under artifact, LineaPy artifact. So here's the artifact we just retrieved, and it has this get code method. And if we run this, we can actually access the exact code that was used to produce this model. It's a short code, so let's actually just walk through it. Import statements, loading of the data, model creation, and training. So this is a very small piece of code. So it seems like there's nothing wrong in here inherently. Now, then our culprit actually moves to the data itself. Okay, the model training, there's nothing wrong with that. Then we may actually suspect that the data that we used, which is the pre-processed data here, might be the wrong. In that case, we can actually repeat the process because we know that it comes from LineaPy as an artifact. Specifically, artifact name is iris preprocessed, and the version that was used was version 2. So we can use the get API again to retrieve this artifact and get the value out of it. And because this is a data artifact, it will be a table. And we can actually try to see if this looks okay. And I know this is a lot of columns, but with some time spent, you will pretty quickly notice that this column, septal width and petal width, are identical here. And of course, this is a table with 150 rows, so chance of this being the real thing is very slim. So we know there's something wrong with this data. And how do we identify like what caused this? And again, we can repeat the same process, which is we can actually check the code that was used to generate this pre-processed data. Again, we are using this get code method. And if we do that, what we get is, there we go. What we get is a code, which is the code that was used to generate this pre-processed data. And this is again like a short piece of code, so we can actually inspect it. And its import statement, loading of what appears to be the raw data because it comes from a web address. And then there's some transformation happening here. And we encountered this line, which looks a little bit weird because what it's doing is it's basically just like overriding this column, septal with this column. And if we actually go up here in this table, these are actually the exact same columns that we spotted as the problematic ones here, septal width and petal width. So this, we can actually identify that this was the step that caused every problem, like all the problems that we just saw, down to the model level. And yeah, this is good to know like where that happened. But then wouldn't it be like better to actually know, have a more context around like why this happened in the first place? So at this point, I actually want to highlight the fact that this is actually very short code. And the reason is because when you run this get code API, then what Lineapi does is it does a smart thing where it only retains the relevant code to generate this artifact. So it actually just ignores all the extraneous ones. However, in this context of an inspection that we are doing, which is detective work, we actually want to see the entire code that was used by the developer. So in that case, what you can use is another API called get session code, and this will return the full session code, including all the comments, as well as all the extraneous parts of the development session. As you can see, this is like a much longer code than what we got above here. And it includes, like a bunch of more import statements, as well as some visualization code. And of course, these are not retained because these are not relevant to the data, pre-processed data. But then what it is useful is because thankfully, the writer of this code actually included some comments in there in his development. And if we scroll down and just eyeball the code, we can actually spot this problematic line that we identified earlier. And it happens to that there's a comment for that. And it says a swap variable. Interesting. So we don't know the full context, but from the comment here, it appears that the writer of this code was trying to swap the variable for some reason. But then what appears to have happened here is he or she didn't do it in the fully, properly. So we only just have a partial implementation of what the person was trying to do here. So this will give us, where the problem had happened and, a better idea of how we can actually resolve this. And let's recap what we learned from this demo. So again, data science is a very collaborative process, and we often rely on somebody else's work, as this demo illustrated. But the truth of the matter is in companies or most organizations, people come and go, and the knowledge transfer when they leave doesn't happen automatically and fully, which actually leads to a problem about the leads to gaps in institutional knowledge. LineaPy, however, because it encapsulates both the value and the code, it can actually help us to easily navigate through the lineage of the artifacts and also the relationships between artifacts, which can actually help us identify this type of a problem without actually relying on the person physically being available. So this is the actually end of the demo, but before we leave, I actually want to do something interesting and give you a small demo of the fact that this is actually a shared artifact store. So like I said, the artifact store I am using right now is hosted on AWS, and what that means is that a colleague of mine who is located in another city, in some different time zone, can actually use the same artifact store, and we can actually exchange the artifacts real time. So what I'm going to do as a part of this mini demo is I'm going to ask my colleague Mingzhi who is in Washington, D.C. area. And he's gonna create an artifact for me. And then he's gonna push it to the shared artifact store. And what I'm gonna show is that I can actually access it in real time and potentially actually leverage that. So let me actually call Mingzhi. Are you there, Mingzhi?
Yes. Can everybody hear me?
Yep, we can hear you. Can you take over?
Yep. So Sangyang and I are working on some natural language processing that about some joke. So I just have a new way to create a joke. So I decided to share with him that how I make the joke. So the welcome is the joke that I just made, and it is a string. And so I'm going to look at what's already in the artifact store. Let's see. Okay, so that looks like the same thing Sangyang just showed me. And since I already have my joke, I'm going to push my joke to the artifact store and let Sangyang review how do I create this joke. So, and what exactly that joke is. So I'm going to do a LineaPy save, and yeah. And let me double check that whether I save my message or not, my artifact or not. Okay, looks like yeah, we have artifact saved. And Sangyang, do you want to review my artifact to see whether this is good or not?
Yeah, sure, Mingzhi. Let me take over. And here's exactly where we left off before I transition to Mingzhi. And let's actually see what he has pushed in there. So for that, first of all, let me check what artifact store currently holds. And voila, here's the artifact that Mingzhi just created and pushed. And I have like a real-time access to that. And let's actually unpack this thing to see what job Mingzhi actually wrapped into. Lineapi Get. And the artifact is called welcome. And the version is 0. And I'm gonna save it to artifact. And if I print, because we're interested in the value of this artifact, let's actually unpack this. And it says, why do programmers confuse Halloween with Christmas? Because October 1st equals December 25th. Oh, okay, Mingzhi, I actually didn't get this, so probably you want to explain? No.
Yeah, because if you count the number in different way, you count it that if you count it, you add one more digit at every 8 number, then it will be equals to 25.
I see. Okay, yes.
Yeah, but you can look at how I generate this artifact, and you see something unexpected actually.
Okay, yeah, interesting. So yeah, let's actually see the code that he used to generate this guy. Oh, interesting. There's a library called the PyJoke. I actually didn't know that. Huh. Interesting. Yeah, cool. So again, this is an illustration of this collaboration. Like it can happen real time because the artifact store is hosted on cloud. You can actually find our documentation to see where exactly, or your own notebook has the explanation about how to set that up. But then unfortunately we cannot allow access to this our cloud to everybody. So in your notebook, what you will instead have will be a frozen copy of the same artifact store, so you can actually reproduce what I just showed you here. But yeah, this is how you share and reproduce the artifacts across different teams. All right, Andy, I'll give it back to you so that you can wrap things up.
Thank you, Sangyang and Mingzhi, and for this awesome PyJoke. I have no idea there's a library called PyJoke. To recap what he just said, here's a function that might be helpful and used in this walkthrough. This slide will be shared with you shortly, so don't worry, we got your cheat sheet ready. Artifact is a core component, but LineaPy does not stop there.
Remembering the pipeline piece I mentioned previously, LineaPy can definitely help you with that too. After you take care of your LineaPy artifacts, you can use call to pipeline API on linear artifacts to create data pipelines by translating raw Python code into data pipeline specification code with a target orchestration framework like Airflow or Task. The file associated with the pipeline include not only the code, but for computing the artifact, but also the Python dependencies for the code and the Docker file to set up a container to run the pipeline with all the right dependencies installed. The pipeline file can then be sent to a workflow orchestration framework like Airflow or Prefect for productionization. We will host another workshop on the pipeline piece in August, so definitely join our Slack and stay updated for this event. Let's now have a recap about LineaPy's workflow. First thing first, we import LineaPy, which begins to capture your workflow and create a linear graph in the background. We then call linea.save on a data science artifact of your interest, which could be a data frame, model, or anything else, and then create a linear artifact, which contains both the artifact value and the code for generating that value. Calling to pipeline to a linear artifact translate it into a pipeline in any target orchestration framework as you prefer. Before we dive into Q&A, I wanted to introduce the LineaPy developer team. Doris, Ifan, Mustafa, and Ayan are from the UC Berkeley Rice Lab, which also create Apache Spark. Shardul comes from a software engineering and operation research background. Both Minjer and Sangyun have been data scientists and data engineers themselves. Our team not only has profound technical knowledge, but years of industry experience. We understand the difficulties and the development environment and trying to provide the best solution to help you here. Okay, that's enough of me talking. Now we're happy to take questions from the audience. Our engineer team will here to answer your questions. Feel free to unmute yourself or just type your questions in the chat box. Okay, if you have any questions, we always have a Slack here, and you can either join the Slack and then we will leave a few minutes. Oh, yeah, we have one from Marcin. Are there any commercial users?
Yeah, the answer is no, because this is a open source library at this moment, and it's in active development. But then so it's a work in progress, and that's where I'm like your contribution and ideas will be very helpful. Yeah, and then yeah, but we are in the discussion with some commercial like partners in terms of development, how it can be actually integrated into be more useful to their contexts.
Another question from Josh. How long does it take to run the full tutorial that was shown today?
Josh, can you clarify your question? Sorry.
If I want to set off and run the tutorial that was shown today in the code lab, what do I set aside? 15, 20 minutes? What's the time that it usually takes to run through?
Oh yeah, without explanations, it's a pretty yeah, I think it'll take maybe under 15 minutes for sure. Yeah, it took longer for us because I had to explain things, but then it should be pretty shorter on your end. And also what you noticed about the delay is because of the network situation now. Like I said, it's because the artifact store is hosted on AWS, and it happens that the area I'm currently in has some weird issue. So that's why there's a lag. But then if you have a better network situation there, then environment, then it'll be quicker to actually load the things.
I have a question. Have you seen any of your users change the behaviors as a result of using this? For example, regarding employee turnaround. Since they have this, are they able to change their behavior in any way that you've noticed?
Sorry, what do you mean by change the behavior?
Have you noticed that your customers have who are using this have been able to make organizational changes to their processes as a result of having this?
Yeah, that's where we want to go, but unfortunately, that has not yet happened. But our hope is that that's the way. That will happen. Yeah, specifically thinking more systematically about where collaboration handoff points will happen. Yeah, that's our kind of a hope. But then as of now, it's more kind of experimentation with our partners, as I mentioned earlier.
Thank you.
A quick note build on from that, we actually have few users from GitHub community. They actually reach out to us and saying the artifact store really solved their issues about having the whole team working on the same project simultaneously by reviewing and pulling the different artifacts from the artifact store. So yeah, we definitely have users having this kind of positive feedback on this piece. And yeah, and if you want to learn more, you can definitely check into our lineapi.org website to learn more about the user testimonies and how we make their data science workflow easier and sufficient.
Thank you.
Of course, anytime.
Cool, thanks, Andy. I didn't know that.
It's time for a product huddle meeting, yeah.
Awesome.
Okay. We're gonna leave a few more minutes by the end of the presentation. So if you have any last minute questions, that will be the place to take care of it. Thank you for everyone's question. Those are really awesome. If you'd like to learn more, you can follow us on all these social channels. It's a big ask, but more channels, more fun activities, and join our Slack to get updated on the features and to meet any other fellow data scientists or data folks in the community. We are working together to solving challenges around productionization of data science and the development. Another fun fact about us is we're actually a swag company, like all the startup company in the United States. Just kidding, but how you can get your very exclusive Lineapi notebook. Here, take a screenshot of the summary slide, which will be shared with you shortly. Write down 3 takeaways from today's workshop. Share your feedback on social media, and then join our Slack to send out your shipping address. We will send you our very exclusive Linea notebook. We will be hosting, if you're watching this from YouTube, you can also be part of this. The rules also applies to you, so definitely don't miss out and do the same thing. We're going to hosting more of these workshops in the future. It is a very consistent movement. So definitely keep an eye out for more information on the workshop session on our social channels. And thank you very much for joining us today. We hope to meet you in the future in either GitHub community or the Slack. This concludes our workshop today. We will keep the Zoom open for another 2 minutes for any additional questions. Have a nice weekend.